Hello, and welcome to the tutorial on deriving discount factors using the bootstrapping technique. In the previous tutorial, we valued cash flows using discount factors. In this tutorial, we look at where the discount factors themselves come from. So remember how we used them last time. The example below should look familiar. We had a 5-year bond with a 6% coupon, cash flows going from year 1 to 5. And we multiplied each cash flow times the discount factor for that period to get the value of that cash flow. We then summed up those values and got the total value, fair value for the bond. But where did the discount factors come from? So that's what we'll look at now. There are a couple of methods. One method is to obtain them directly from traded zero coupon bond prices. So if we have zero coupon bonds for each required maturity date, those prices directly give us the discount factors, as shown in the example below. So we have here a 1-year zero out to a 5-year zero. Each of those is zero coupon, so they're single cash flow instruments with prices, and those prices represent the discount factors. But we may not have zero coupons going out so far. Now, they're typically zero coupon bonds with maturities out to about a year. These are called bills. But longer maturity bonds typically pay intermediate coupons. Now, we can derive discount factors from those as well, but it requires a bit more work. So consider this example. We've got a 1-year bill, but then for years 2 through 5, those are coupon-bearing bonds. So those are multi-cash flow bonds. How do we get the discount factors in this case? Well, the first year is okay. That's 0.97, just as we saw before. But what about year 2? So year 2 is not a zero coupon. It's a bullet bond with intermediate coupon in year 1. So here we see the cash flows. We have a 5% coupon, so it pays 5 and 105 principal and interest in year 2. We have the discount factor for the first year from the T-bill, but we don't have it for the second. So we can value the cash flow by multiplying cash flow by discount factors we've done before, and we get 485. We know the total value of the bond is 101.45. And we can use that then to derive the value of the second cash flow because the sum together must equal 101.45. So if we subtract 485 from 101.45, we get the remainder, which is attributable to the second cash flow. Now we can get the discount factor from that by noting that the value of this second cash flow is 96.60 and the amount is 105. So the discount factor is the ratio of the two. So 96.60 today buys 105 in year 2, and that gives us a discount factor of 0.92. So we can add that to our table. So let's move on then to a 3-year bond. Now here it's a different bond with different cash flows, a different coupon, but it also has cash flows occurring in year 1 and 2, and we have discount factors for those, the 0.97 and the 0.92 we just calculated. So we can value the cash flow values for each of these. We can sum them, and we can then subtract that from the total value of the bond. So the total value of the bond is 97. We subtract 756, and we get this 89.44. And that 89.44 then is the value of that third cash flow, the 104. So divide the 89.44 by the 104, and we get the discount factor for the third period, 0.86. So you can kind of see how this is going. We essentially have 3 steps. Step 1 is we value the intermediate cash flows using the previously obtained discount factors. Step 2 is we value the last cash flow by subtracting the intermediate cash flows from the value of the total bond. And then step 3, we value the discount factor itself by looking at the ratio of the value to the amount of that final cash flow. We can also look at this in algebraic terms. So the formula here essentially shows what the price of a bond with face value of 1, coupon rate, and we see here the value of the intermediate cash flows, This is the amount of the coupon. This is the amount of the discount factors. So that gives us the value of the intermediate coupons. This is the value of the last cash flow because we're getting 1 plus a coupon times the discount factor, which we don't know yet. And those sum to be P, the price of the bond. So we know P, we know the coupon rate, we know all the discount factors except for the last one. And so we can rearrange and solve for the value of that last cash flow. And that gives us this formula here. So let's apply this in Excel. We could do this in our calculator, but it would get tedious and easy to make a mistake. But it's pretty easy to set up an Excel spreadsheet that will do this. So we have here our bonds in each row. So maturities 1 through 5. These are the coupons and the prices, current market prices for those bonds. And let's say we've calculated the discount factors for all of them, the first 4. And we're looking at the 5th one. So the 5th one is going to have this formula in it, as did the previous cells. And we can see here how it's implemented in Excel. So we're subtracting from the price, this 99.74 or 0.9974 in decimal form, minus the coupon rate times all the previous discount factors. So that's this right here. And then dividing that by 1 plus C. And that will give us the discount factor of 0.74. So that's how we do it. So let's summarize some final thoughts on deriving discount factors. Discount factors are used to value cash flows, and those discount factors can be derived from the market price of traded bonds. We can derive it directly from the price of zero coupon bonds, which their price effectively is the discount factor, or we can use the bootstrapping technique that we've just gone over to derive discount factors using the market prices of coupon-bearing bonds. And I should note that while the illustration that we went through was, of course, the cleanest possible, the maturities were exactly 1 year apart, there were no gaps. I would note that the bootstrapping technique can still be used. It would have to be modified, but it can be used to work with uneven bond maturities and gaps. So that's it. Thank you very much for listening.